Um, Good afternoon to all of you. I know it's late afternoon there. I'm joining you today from Washington, D.C. in the United States. And here it is still dark out, early morning. So um, hopefully everyone is doing well. And thank you for inviting me to this event and giving me some time to speak to you. As you can see on the screen, my name is Paul Lebar. I am the Vice President of Innovation at Software Productivity Strategists. SBS is helping to bring this program to you today. So it's a great opportunity for me to talk to you all a little bit on this day today. And as the VP of Innovation, I have a pretty interesting set of responsibilities. So we look at new and emerging technologies. We look at the possibilities of using those technologies in applications for our customers, and I lead the team that does the development on those technologies, and we incorporate them different techniques and different methodologies to work with that. Of course, we look for great partners that can help us do that as well as reaching out to the community like we're doing today to help enable the community on those technologies and help us understand how those new and emerging technologies work, how we can best use them, and how we can work with all of you to make real solutions that are useful in the real world. And so one of the things that is true of our time is that innovation is allowing businesses to completely disrupt industries where there are long established companies with seemingly insurmountable leads in terms of those incumbents, infrastructure and process and sheer size. But if you look at what's happened, with some of the companies that have become the largest and most well-recognized companies in the world over the last years, you see how information technology has brought about massive disruption. Now, this chart is I think a particularly nice way of presenting what's become sort of a business world meme, if you will, about some of these companies. Uber, which owns no cars yet, is the largest taxi type service in the world. Airbnb, which owns no hotels, owns no real estate yet is the largest accommodation company in the world, larger than the Hilton chain, larger than Marriott's chain, who own massive amounts of infrastructure, tons of property, have to be able to maintain those properties and pay employees to man them, et cetera, et cetera. Alibaba, which carries no inventory of their own, yet is the world's largest retailer, and competes with the likes of Walmart, on a global scale, and is able to sell more retail than a chain like Walmart that invests massively in warehousing and transportation and all of those things to maintain their inventory. Huge amounts of investment in storefront property. Gigantic box stores with massive square footage that have to be owned and maintained, et cetera, et cetera. And the world's largest media company, Facebook, that owns no content yet has completely redefined what a media company is in terms of their ability to offer compelling media to literally billions of people. So these companies were able to disrupt because they started with information technology and grew around that. They and they leveraged that technology to gain a lead over those competitors that had made massive investments in their infrastructure, but were not necessarily thinking about disrupting their own businesses, not thinking about how is the industry going to be changed, how will new technology allow us to do our business differently, do our business in a way that throws away these decades, or in some cases centuries old notions of how this company is this industry is supposed to run, and how can we totally redo this just based on technology. So we're in this age right now of massive disruption through the use of emerging internet technologies. But what's interesting about that is we're not really in the age of disruption. Technology disrupting the world has existed as long as history. The story of iron is a example. So when the techniques to extract the iron metal from iron ore developed, it quickly proliferated around the world. And what was interesting is that the techniques to build tools and weapons out of metal were fairly complex, and the availability of the metals to build weapons and tools was fairly limited. But once the ability to make those tools out of iron developed, there was massive expansion in the ability to manufacture tools and weapons, and this changed the globe. For one, the ability to arm massive numbers of people and grow huge armies suddenly became a reality. And on the flip side, iron farming tools greatly increased agricultural productivity, and populations started to balloon. And so you were able to, as a small state, grow your population, arm all of your people, and have both large numbers of people to do lots of things for your state, as well as the ability to create lots of tools and weapons very quickly. And that resulted in small states starting to overwhelm and consume other states to build larger states. And so you saw a complete change in how the people of the world were governed, and how they were organized, and how they dealt with each other. And you saw the rise of forms of government like the imperium and democracy. So here was technology, literally thousands of years ago, completely disrupting the way humans live. It basically took that very specialized and very limited ability and to make metal tools, and democratized it, made it available to everyone, sort of in the way Facebook has made content creation available to everyone. Facebook and its counterparts like YouTube and other social media platforms has made the creation of content available to everyone. Another very interesting and a little more current story of disruption is SpaceX. Now they've certainly had their ups and downs, but they're up right now, having just successfully launched the Falcon Heavy flight. And again, here's the idea of technology and new techniques, new ways of thinking about how space flight and space exploration vehicles can be developed, causing disruption in a field that previously had been dominated only by very large and very wealthy governments. The quote here is from one of their engineers, David GIKI, and he says SpaceX was built on test, test. We test as we fly. So it's a different way of thinking about spaceflight. Spaceflight was previously thought of as get everything perfect and then fly and make sure everything is extra perfect. SpaceX said, you know what, we're starting from a clean slate. We're starting a business exploration where our business has never done that before. We're going to be testing constantly, and we're going to be refining constantly, and we're going to be improving constantly. And if we fail on a flight, we're just going to pick up and keep moving forward. And so that mentality, as much as the technology, has allowed them to completely disrupt, an industry that, as I said, was dominated by large, wealthy governments. I would certainly have not thought in my lifetime I would see a non-government entity dominating the world of space flight. So, just again, another great example of innovation disrupting an industry. So certainly technology is an enabler to this innovation, and so I want to talk a little bit about technologies that we at SPS use today. There's two technologies that really are allowing us to do some really interesting and really cool things with our customers right now. And they both happen to be IBM technologies, although certainly there are counterparts to some of this technology from other manufacturers and other service providers. We've ended up working mostly with the IBM technology for two reasons. One, when we talk about Watson and Watson's cognitive capabilities, they are more extensive than any other offering out there right now. And two, with Bluemix and Platform as a Service, we find that their offering has some key advantages in terms of ease of use, in terms of open source, usage and openness, and so we've aligned ourselves more closely with IBM than some of the other vendors. Now, what's very interesting about how they have implemented Watson, and I'm sure many of you or all of you are aware of kind of how Watson got its start playing chess and also playing Jeopardy. The paradigm for Watson now really fits interestingly with that kind of idea of making technology available on a much wider scale and how that can disrupt the world. So you see listed here different icons and their titles, and what these represent are services that are offered by IBM, and these services can be easily tapped into through REST APIs and incorporated into whatever application you seek to use. Now, with existing examples of customer implementations that we have built or in the process of building, we've seen the services used as their own, on their own, and used to literally enhance an app that is otherwise running in our customers' infrastructure. We've also seen cases where the app runs completely on the cloud, and so they run side by side with the services that they're using on the cloud. But that capability to just tap into again makes it available to use in a huge variety of ways. And each of these different services listed here has a different capability that is based not on traditional, traditional processing and traditional technology, but on cognitive technology that under its covers is implemented using AI techniques or AI technologies like neural networks, etc. And so each one of them performs a different type of task that is not easily performed by traditional applications in traditional computing settings, but are in these cases and cognitive cases are actually powered by the concept of machine learning. Some of them are pre-trained. They come, sort of off the shelf, having been trained by IBM and IBM's engineers to perform a certain task, and others can be enhanced with your own training. And those services provide the tool sets that allow you to do that training. The Discovery service is a great example of that. Discovery service is meant to do text analytics and cognitive searching of text from unstructured data. And as I said, as I was describing, this comes with an off-the-shelf capability based on how language is traditionally used, and multiple different languages. But it can also be trained through the development of custom models. And there are tools that IBM provides you, namely one called the Watson Knowledge Studio, where you actually go in and perform the training. Humans go in and perform the task of perform the task of annotation, which is marking up the actual examples of the text that you want Discovery service to be able to analyze and understand. And that human annotation task allows the building of a custom model that then trains the Discovery service to recognize the specific parts of that article that you care about. So you train it in your specific language and in the language that you use in your business, in the information that is important to you in your business, and enhance it in a way that's unique and completely domain specific based on the domain that you care about. So as you can see, they offer, the different services offer a myriad of different capabilities, everything ranging from what I was just describing in Discovery service, which analyzes text, to something like Personality Insights, which analyzes text for insights into a person's personality traits. All the way through to something like visual recognition, which analyzes images to be able to tell you what's in an image. I'll talk a little bit later about something we're actually working on right now with visual recognition that I think will demonstrate exactly how useful that is. Now, those services, as I said, those are available, and we can incorporate those in applications through REST APIs as we want. But the other thing that is making innovation possible for us is the Bluemix platform. And there are other choices out there that have similar capabilities, but Bluemix is platform as a service. And so generically speaking, the idea of platform as a service is really a stunning change in how IT is done that's occurred over the last decade. Now, cloud, has been around for a while, and the idea of cloud infrastructure has been around for a while. What platform as a service adds on top of infrastructure as a service that really makes a huge difference is obviously the compute and memory and all of that is available on the cloud as part of platform as a service, and that in and of itself is a huge game changer. But what platform as a service adds on top of that is the ability to spin up a runtime environment with no need for an administrator to go in and configure an operating system and install the runtime environment and configure all the networking that needs to happen to allow you to connect to that runtime environment and for your application to be available to the world outside. And so tasks that literally in our world could take 2 weeks to, stand up a server, make sure everything's configured right, install the middleware that we wanted to run our application on, configure that middleware for security and the database connections and all that can be done in literally hours with platform as a service. You push a button to stand up your runtime, you add in services for your databases, you configure security, and you're off and running. You don't install anything. It's all basically installed for you. And so that ability to literally have a runtime environment that you're using for your development and the same day that you decide to start doing a project is just it's just a stunning change in how we do our work. And so it makes the time and the cost to just go test out an idea feasible. You would in the past, if you wanted to develop an enterprise class application, you would have to really think about whether or not it was worth standing up the infrastructure to do that, and you would study it and analyze it and make some decisions after weeks of consideration and a lot of debate and going back and forth. And now there's almost no time or money spent to just stand up an environment to start playing around in. And so the decision is much easier to make and much quicker to just prove to yourself if the technology is going to work to solve your problem than trying to think about it. You just go do it. It's that easy. So it really is a massive game changer in terms of the capability that's there. So then the question is this important? Well, analysts who are looking at this stuff say there's some indications that, yeah, this stuff is becoming very important. And it's for all of you, it's important. In terms of cognitive, the Watson stuff, by 2018, which we're there now, 50% of developer teams will embed cognitive capability in their apps. If it's 50% now, it's and this stuff has only been around for a couple of years. That's an incredible rate of adoption. So knowing cognitive and being able to work with cognitive is going to be a requirement to be a developer in almost all cases in the very near future. It's already being used on half of development teams. In addition to that, 80% of enterprises will overhaul their digital front door by 2018. So changing their UI, changing how their look and feel, it is happening in almost every enterprise, and that's going to be enabled by things like platform as a service, because you can very rapidly develop that on platform as a service, and you can use that to enable things like split tests, because you can set up multiple infrastructures and try out different ideas with customers and see which ones work best, so that what you develop for that new user experience is the best one you can get out there, and you can get feedback from your users and make sure that they like it before you roll it out 100% across the board. And so this UX development is being enabled by those technologies as well. The other thing that analysts are saying is that 80% of organizations that are trying to do this themselves won't achieve their expectations and goals around their own DIY platform as a service. So that means that the big the big manufacturers, the big service providers who are offering platform as a service are going to be the solution of choice going forward, and that makes perfect sense if you think about it. Huge organizations like Microsoft and IBM and Google and Amazon have, thousands of people working in their data centers and working on their cloud platforms. Even the largest organizations that are not devoted to that type of business can't possibly have as many people working on it, understanding it, the breadth and depth of expertise in setting up and maintaining and securing an IT infrastructure. And so of course the large providers who are making these platforms available are going to do it better. And the idea of organizations owning and managing their own IT infrastructure, whether it's platform as a service or otherwise, it is definitely going to change massively, and the move to cloud is going to continue as we go forward. And so these technologies are of course going to be necessary for everyone in the IT industry to understand going forward. So we've talked about the technologies and their applicability and their importance and how they're changing the world. The other aspect of innovation is how you innovate. And so so from an SPS perspective, we take a lot of our ideas about innovation and how we innovate from Lean Startup, and we've adapted what's in Lean Startup to our own our own capabilities, our customers' needs, and apply that to our own business. And so the Lean Startup concept really focuses around the creation of an MVP, a minimum viable product. And that's a term, it's a loaded term, the minimum viable product, because so many people interpret it in so many different ways. But if you really strip it down back to how it was originally defined, the minimum viable product is the outcome of the least amount of work you can do that generates the most value for you. And that value is measured in something called validated learning. And so the concept of the minimum viable product is develop something that you can put in front of your customers or your users as rapidly as possible, that gives them an idea of what it's going to do so that they can start giving you feedback. It presumes that you're never going to guess at the beginning exactly what solution your customers or users want, but the more rapidly and the more frequently you can put it in front of them, let them kind of see it, feel it, tinker with it, maybe use it and experience it, the more you can learn about your users and your customers and what they actually really want. Most of the time, when you're developing an application or developing a new capability for your customers, even they can't tell you what they want until after they've seen it and touched it and played around with it and felt it. And so this idea of a minimum viable product really resonates with me and with a lot of other practitioners who have been doing this for 25 plus years or longer, and say, yeah, this all makes sense. And so the technology and the methodology go hand in hand. If we go back to what I was saying about platform as a service, and you think about that a little bit, the ability to build those things with no upfront time and cost with platform as a service, and the ability to tap into capabilities like cognitive that goes so far beyond anything we could do ourselves, but that we can access almost instantly through API calls, really makes this possible. So in a couple of weeks, you could stand up an application with a pretty good user interface and cognitive capabilities incorporated. You know, you can actually really do that, and you can put it in front of your customer, and you can get their feedback, and you can iterate on it again, and come back another 2 weeks later with something even better that incorporates all of their ideas and their feedback. It's definitely for real. We've definitely done it, and we've definitely been able to delight customers doing it. As a result, a little bit about SPS ourselves. We have been able to take the technology and the techniques and all that and just do some really great things. So just to take a minute to toot our own horn about how this actually works. We are a 2-time winner of the ABNet Bluemix with Watson Hackathon. So those are events that are sponsored by a global distributor of technology, in which we've participated with, you know, competing against teams from around the globe that are, you know, all experienced technology implementers, and won both times that we've entered. So it's really you know, the technology and the technique have really allowed us to be successful in those ways. We also on our staff have 2 IBM Cloud Champions. So the solutions that we've built, the ways we've engaged with the technology have been recognized again through global recognition of members of our team. We were semi-finalists in the IBM Cognitive Build Challenge, which again was another global competition with you know, technology implementers from around the world, and we were a semi-finalist there. And we've also been recognized for our expertise by being asked by global training partners to build their training material. So they've recognized how knowledgeable and how deep our knowledge goes, to the extent that that they've asked us to build the material that will be used to teach other people these technologies. And we've also we've implemented dozens of customer projects, and again, like I said, use that technique to delight our customers and build really cool, innovative stuff. The ways that we do that, we call innovation as a service, and so this is just our different ways of engaging with our customers and our clients and apply that technology. So one of the things that becomes very important anytime you're talking about working with a customer to help them build build a solution on one of these technologies is making sure that the leaders in their organization understand the value. And so we do a session with companies leaders called Sparking Innovation through IoT, Cognitive Analytics, and Cloud. And that's really a way to sit down with them and make sure that they aren't, you know, that they don't become, you know, something like a Marriott or a traditional yellow cab or, you know, or a brick and mortar retailer where they get disrupted, where because they haven't been thinking about innovation and they've been ignoring the possibilities, they actually get surpassed by one of their competitors or a totally new player in their industry. And so that conversation, that Sparking Innovation conversation, is all about realizing that the technologies have emerged to affect their industry and change it, and that they want to make sure that they're thinking about how the technology is going to help them solve their problems, so that they're not left behind, so that they're not disrupted, so that they are the innovators in their industry. It's amazing to realize that leaders of organizations, CEOs, CIOs, CTOs aren't necessarily thinking about innovation as their top priority. They've got to keep their business running as it is. They've got to keep the lights on. And innovation is actually kind of scary when you think about it, because they're established and what they're doing has already worked. And so having to think about disruption and innovation, like I said, it's kind of scary. And so we need to kind of open their eyes to the possibilities and show them that, hey, these technologies are game changers. And if you're not going to if you're not going to innovate, you're not going to be a player in the new game when it does. One of the things that sort of helps our customers decide on how they're going to innovate, what problems they're going to solve, which ones they're going to prioritize, are something called innovation value assessments. And this is an important process to go through, because what it does is it allows you to rationalize the value of solving one of these problems. And so we do analysis that allows us to determine, what the impact will be on their business, what value it will bring, if that value is measurable in dollars, if that value is measurable in customer satisfaction, if that value is measurable in prestige. But making sure that we understand, how is creating the solution, how's innovating going to bring new value to your company, and then based on that value, decide which problems or which innovations are of highest priority, and then start working on those. Start working on the ones that are the highest priority and start tackling those through MVP creation. So rapidly iterating on an idea, building out something that they can learn from, that they can measure and understand and get feedback and come to the best solution possible. Of course, there are a lot of organizations out there, and people who are not necessarily organizations, who would really benefit from enablement. And so this is an area where I have particular passion. Prior to being the VP of Innovation at SPS, I was an executive in a global training provider division of an organization. And so I've seen how traditional training works, how instructor-led training works, how it's being consumed, how it's being created, and how both instructor-led and self-paced online training, what they're good for and how they're not necessarily good for all situations. So in that role, I also saw how some new ideas about enablement can really change, how we're teaching people to use these new technologies. And so one of those is the concept of virtual hackathons. And hackathons are a great way to enhance and solidify learning. So courses and instruction teach you how to use a technology, how to understand it, what the terminology is, what the techniques are, etc. But what traditional training and what traditional courses don't necessarily teach you is how to take that knowledge and apply it to a novel problem. The mental exercise of taking your knowledge and applying it to a new problem and having to be inventive and creative in solving that new problem is a totally different process than just learning the techniques and the tools and the vocabulary, etc. And so hackathons give everyone a sort of safe in which to do that. There's no negative consequences to participating. Nobody's going to go out of business. Nobody's going to lose money. And if you do great at it, you win a prize, and you have the pride of having won. But if you don't win, it's not like that's the end of the world. You've learned from the experience. And so like I said, the idea of hackathons are a great way to enhance learning, to give a bridge from the sort of course knowledge to understanding how that technology can be applied in new and different ways. One of the other things that we have here around innovation enablement is the Spin Lab Innovation Center, which is out of our office in Islamabad, and it's a place where we run special interest groups. We we have tech talks and gatherings. We run hackathons out of our Spin Lab Innovation Center. It's a place where people can gather to share ideas and where they can also participate in a lot of different activities that help them engage with technology and learn technology and take things beyond their standard learning and collaborate with other people, other like-minded people who are looking to be innovative and use new technology. And all those things are ways in which we offer our innovation as a service. Now, the result of those things has been a couple of different, not a couple of, literally, dozens of different interesting solutions, but I'll talk about a couple of them that we've implemented just to give you an idea of how the technology kind of comes to bear. So one of the projects we built is something called Social Feel. Now this uses Watson to analyze input from social media, and the real key here is that it's using Watson's ability to understand the emotional sentiment of unstructured information. So basically, we look at social media and basically allow a user to search around a particular topic and get back the sentiment around that topic. Most social media platforms have some way of tracking, like likes or some form of agreement or some form of how people react to it or a particular post, but it doesn't necessarily tell you if that post was positive about whatever subject it was on or negative. I mean, you can like a post that's very critical, that's very negative, and if 100,000 people like that, you don't necessarily know that they're agreeing with a negative idea. And so, say for example, you put a new product out there and you're tracking social media, and somebody says, "I tried this and it's a piece of garbage," and 100,000 people like that comment. Well, if you just go by likes, you'd think 100,000 people are agreeing that your product, that they quote like your product. Understanding the sentiment of that statement and all the other statements that are being made out there, all the other posts out there on social media, gives you more insight into what people are really saying. In addition to that, we're able to break down that sentiment by geography, break it down by demographics, break it down by the time frame of how it's trending over a certain period of time. And so all of this social media analytics and being able to use the cognitive capabilities of Watson to understand what the real sentiment of what's being said on social media is really creates a added value to looking at what's out there on social media. And again, since we're using Watson's cognitive capability to do this, we didn't have to invent the algorithms that determine what the sentiment of a particular statement is. We were able to tap into those, more or less instantly, to be able to use that to analyze what's going on in these different social media posts. Another area where we've applied Watson is in the areas of chatbot, and Watson has a service called the Conversation Service that was essentially created to enable what are called chatbots. Now, the task of having a automated chat with a real person is actually a fairly complex task, especially since you really don't know what the person on the other end is going to say. And so using cognitive capability to understand and interpret what the other person is saying, and then be able to to navigate a conversation script and respond to them in an appropriate way based on what they've said to you, is actually could be very challenging if you don't have a service like the conversation service to help you do that. What we talk about here is a project we did called the Chatbot Jumpstart. It's actually started as an implementation we did for one of our customers specifically, but we built out the actual chat using the conversation service, and also did some of our own work to integrate with Salesforce.com at the back end. And so this illustrates two things. One, it illustrates that, again, we were able to very rapidly develop a capability using, the cognitive services to do something that we certainly wouldn't have been able to do, writing traditional on our own. But we were also able to add value on top of that, that cognitive capability by integrating with our customers' infrastructure. So, the value for the customer in integrating with Salesforce is that we're able to take what occurs in the conversation and what we learn about the customer and about their questions and their issues, and put it into a case management system that's running on Salesforce.com. That means that later on, if that customer calls again, or if the problem that the customer is chatting with the chatbot about requires follow-up, there's a record of that, and it goes into the system that the customers had already been using as part of their infrastructure, to do that follow-up and to be able to recall what that customer had previously called about if they call again, et cetera, et cetera. And so it's enhancing their customer experience by giving the customer the ability to chat and not have to necessarily wait in a call queue for a live person to answer the phone. But it's not just enhancing their customer experience, it's integrating into part of their customer experience. And so like I said, there's that ability to add value on top of what Watson does. Now, the one other example I'll talk about is about what we're doing with the Watson visual recognition. So we have a customer right now who is able to fly over utility lines, power lines, and with drones, and capture images of everything along that power line, including the towers, the lines themselves, as well as the towers that hold those lines up. And believe it or not, that the ability to just recognize that there is a tower present in an image is something that has great value. Right now, our customer that does this, that has the drones fly over the lines and look at those towers, has people who are engineers look at images and determine which ones have a tower in them and which ones don't. So every single image has to be inspected by a person. And if you think about that, if you're really good and really fast, how many images can you look at in a day? A couple hundred, maybe. A computer can look at thousands, tens of thousands. The only limit is how many compute cycles you give it, and so the value of being able to look at these images and determine which ones have towers and which ones don't is extremely valuable, because now the humans that are going to be inspecting these images don't have to look at the images that don't have valuable information in them. Furthermore, the goal of looking at the images of towers is to determine if there are towers that are in need of repair. Well, if the computer can look at that and determine which ones need repair, then you don't need the humans to do that at all. You need the humans just to go in and do double checks or look at images that the computer basically said were borderline cases. You're reducing the need to add a staff of 100 inspectors down to a handful of inspectors by allowing Watson to recognize that there are towers in these images and recognize that those towers have damage. Well, Watson doesn't do that out of the box or off the shelf. It certainly doesn't recognize damage to a tower or a tower that needs repair. And so part of the task is actually training Watson, giving it examples of images that show damage or show need for repair, and basically telling it this is what a damaged tower looks like. This is what this is what a tower looks like. This is what an image with no tower it looks like. And so training Watson with hundreds or maybe thousands of images that showed positive and negative cases of images that contain towers or towers that need repair, etc. But the impact is it's easy to see. If you can analyze thousands of images a day rather than hundreds, you're able to do this work at the rate that the images are captured. The drones that have forward and backwards looking cameras, they capture thousands of images a day. They fly over a line and they're taking images every in fractions of a second. Some of these lines are hundreds of miles long, so they're flying 6 hours a day and they're capturing multiple images per second. So I mean the volume of images to analyze is gigantic. So anyway, so it's a really intriguing problem. It's one that we know we can clearly solve with the kind of capabilities and just an exciting project to be working on right now. So with that, I've reached the end of my presentation. I hope it gave you some valuable insights and valuable knowledge on what's going on in our world, what's going on in the industry, how techniques and technologies are changing the way we do things in that industry, and that it's given you a flavor for some of the exciting kinds of applications that we're able to build now with these new technologies and techniques. With that, I'll say again, thank you very much for listening to me today. I really appreciate it, and I will hand things back over to Sajid. So Sajid, over to you.
Yeah, thank you, Paul. It was a great session. Everybody is sitting here. So, guys, if somebody have any question, regarding the innovation or regarding any technology, relevant to innovation, so feel free to ask here. So he's available with us. Yes. Yeah. So basically, it's a service over the cloud. So once you can be access to cloud, so you can use that. All right. Anyone else? Right? So the idea of cloud, we don't know about cloud. So it's about the idea of cloud is there are a number of clouds in the market, like Microsoft has, Microsoft Azure. Similarly, Google is the IBM cloud. New name is totally changed, now known as IBM cloud, but the previous name was all right. All right. Any other question, guys?
Hello? Hello, can you hear me?
Yes, I can hear you.
Well, I have a question regarding blockchain.
Okay.
When we transit accounts or information in blockchain, it makes multiple blocks of it. For example, in a peer-to-peer system, it distributes its image over all the databases there are, right?
Yes.
Yeah. My question is, what if we make a mistake while making one of the transactions there? The image of that database is present on each and every PC, each and every distributed system there is. So if you want to correct or rectify that thing, it would take a lot of time and a lot of computation power, because then you have to, according to what I'm thinking here right now is, then you would have to clear that image or erase that the particular transaction from each and every image there is on the blockchain, right?
Yes. What you're saying so far is accurate.
So,
So
does it make blockchain difficult to use? Because what if you make an error while transacting something, or making an image of it on different images of the database there is?
well, so the question is, I mean, in the abstract, does it make blockchain difficult to use? Blockchain obviously doesn't handle that issue as well as, say, a single database would. It's it's an it's a trade-off to what blockchain does, the advantages that blockchain does offer. So if you made a mistake, and it was the mistake itself passed the threshold for consensus, and was committed to the blockchain. The way you would undo that mistake is by adding another block to the chain. And so you would go through the same process as you would for any other update or any other transaction to the blockchain. Because remember, one of the things that blockchain um, uh, imposes is that the record is immutable. So in a single database scenario, you could theoretically go in and delete a record that was added in error, right? You could perform a delete command and delete it, or you could perform an update command and update that data. Blockchain doesn't allow you to do that. So, um, so in that sense, yes, it's much less efficient than having a single centralized database. The idea of having the distributed information across the entire business network that's participating in blockchain and having consensus is that you don't have a single entity that's in control of the data. And so by having multiple, multiple participants in the business network in control of the data, you are guaranteeing that the data can't be essentially manipulated by a single actor. So yes, your trade-off in protecting the data by not allowing a single actor to change it and having an immutable record is that when you need to make a change, or even when you need to make an update that's not an error, it's just an update, you do have to do it across the entire business network, and that does take more compute cycles than if there were a single owner of the data making a single database update. It's actually it's a discussion about Bitcoin and Bitcoin's blockchain implementation that the consensus algorithm is very heavyweight, and so when you get down to things like the raw power consumption that's involved in Bitcoin, because of their complicated consensus algorithm, it actually may not be a practical way to run global commerce because it consumes so much energy. so yes, it's a trade-off, and it's one that's sort of assumed to be valuable, because that consensus guarantees that no single actor can manipulate the data.
Uh, my follow-up question to that is, for us, the new developers there, we are looking blockchain as not only a Bitcoin development thing, but as a technology which can be used to develop multiple things. For example, it can be a degree verification system for the entire world to be on there. So if there is a search system there for degree verification, my question is, what if there is a wrong record and the system is trying to rectify the record, but because it takes so much computation power that it has to change each and every single image of it, but while on the other hand, at the same runtime or at a dynamic time, some other user is trying to access or search for that particular degree or any other search there is. So what would be the reaction of blockchain on that?
So the question is if they're searching for information while the blockchain is also being updated. Most likely, so you're describing a situation where information was committed to the blockchain and it passed the consensus threshold, so it was accepted as a change, but it was just, it was keyed in an error, right? In your case, it's a degree verification system, and the person's name was typed with an N where it should have an M, right? And that somehow passed through that passed consensus and was committed to the blockchain. In a case like that, if the search was performed before a correction was made and consensus was reached on that correction, they would probably get back the erroneous record. The idea that so again, theoretically in blockchain, if you enter data that's incorrect, it should not, the consensus algorithm should prevent the incorrect data from being committed to the blockchain. But of course, what is how that consensus is reached and whether or not the error in the data is significant or not. You could have something that was, fat finger typing on somebody's part or something like that. Get in there. Geez, I lost my train of thought on what I was going to say there. I think the point being, there could be something in there that's incorrect, and if it's been committed, then when people search that data, they'll see what's incorrect. That's true of any system anywhere. If the system doesn't have the right checks on the data being entered, there could be a mistake made.
So to search data in any blockchain system, we would just have to search the closest block there is.
Well, one of the things that it can happen in blockchain is that different participants who have a copy of the ledger can create their own interfaces into that data. So where that data is coming from, it depends on which interface you're using. So, if I want to give people the ability to search the data in the blockchain, I have to write some sort of front-end application that allows them to search the data. So as the creator of that front-end interface, I would determine how they would access the ledger. In current implementations, the blockchain technology, the implementation of the blockchain technology is being offered by different providers as a service, and so basically you would access the data through service calls.
My last question is, if I want to be over ambitious and want to hack blockchain, do I have to brutally hack each and every image there is there simultaneously?
I'm sorry, if you wanted to hack the blockchain ledger,
Yes.
Is that the question?
Yes, if I want to hack any record on blockchain ledger, do I have to hack all the images there is simultaneously using brute force?
Well, you'd have to hack at least 51%. So that's basically because changes to the blockchain ledger are by consensus. You'd have to have 51% of the the copies of the ledger. You'd have to be able to hack those. So you don't have to get all of them. What you're more likely, what's more likely to work, and what has actually happened with some cryptocurrencies is, I was just describing that if you are a participant in a blockchain, then you have an ability to write applications um, that interface with the blockchain, and so you could, for example, put a transaction out there, let it go through the blockchain network and go through consensus and be accepted. So if you write an application that puts a new transaction out there, and it, hacking that application is more likely to work than trying to hack the ledger itself. So, for example, if you're dealing with cryptocurrency, and this will be oversimplified, there are transactional systems that allow you to buy something with cryptocurrency, right? And the transaction itself has to be entered in through an application. And so, if you hack that application and make a transaction that looks valid, that's a more likely way to hack the system. And like I said, that actually did happen with that has actually happened with cryptocurrencies.
Thank you so much for your time and for answering my questions.
You're welcome.
So, Paul, we have a very senior faculty member here, and he is very interested to see some demo which we are working on. So, is this possible right now?
Oh, boy, why don't we set up a follow-up time to do a
Yeah.
demonstration?
Yes.
I didn't really have anything ready for demo for
Yes.
today, so
Definitely.
let me apologize
Sure. Sure.
for not being able to do that today. But let's absolutely do follow up, and I'll walk you through some demos. I'd be happy to do that.
Sure. Perfect. Perfect. All right. Anyone else have any questions right now? All right. All right. We have one last question here.
Okay, so I have a question regarding chatbots. We have common chatbots like Siri, the Google Assistant. Now you've talked about IBM Watson. Can you tell me how reliable they can be? Because people rely to them. So what is the probability that they're correct? They give correct responses every time. Thank you.
But the the answer to that is it depends. So one of the things that I mentioned about the chatbots is they'll interpret what the person on the other, what the person is saying, and understand that using using cognitive algorithms to understand the natural language. Whether or not they're correct in the case of using the Watson Conversation API, whether or not they're correct depends on how well you've set up the rest of your chatbot implementation. So the chatbot replies with a set of responses that you've given it to respond with, right? So it doesn't make up its own response on the fly. You know, if for example, you know, you've set up your chatbot to work in a customer service scenario, and the customer, I want to complain, I want to, you know, register a complaint about the service that I received. How the chatbot responds to that is something that you configure. You know, you would, you know, most likely, you know, the chatbot would say, "I'm really sorry to hear that you had an issue. Can you tell me more about it?" Right? That response is something that you put into the conversation service as a configuration. Whether or not it recognizes that the customer is saying, "I want to complain about something," also depends to some extent on your configuration and to some extent on the algorithm. The reason my first answer was it depends is you certainly need to, when you implement a unique conversation service, you need to do the same work you would do with any other application, which is you need to write test cases. You need to run through those test cases. You need to understand what the variances are around those test cases. And they actually get more complicated with something like a chatbot because, you know, generally when you're writing test cases for an application, there's only one input that's possible. With a chatbot, the input can be it can vary quite a bit, so you need to write those test cases to take into account that there's variation in how people express themselves. Ultimately, I can't give you a number like, oh, it's 99% accurate. It really depends on how you've built your application, how well you've tested your application, what scenario you're using what scenario you're applying the application to, and just how thorough your work has been. For the ones that are more general, the Siris and the Alexas and things like that, their accuracy is even more complicated by the fact that it's doing voice recognition as well as interpreting the spoken language. So you're introducing another factor that can introduce inaccuracy by adding in the voice recognition. So I imagine that companies like Amazon and like Apple are also doing like amazingly expensive testing to get things like Siri and Alexa to work as well as they do. I think furthermore, around the voice recognition part of it, the fact that those applications are now cloud-based, I think has improved the accuracy of those applications and their voice recognition capabilities considerably. If you used voice recognition systems that were installed locally, things like Dragon Speak or something like that, they would be trained specifically to you. You would train them. They were trained to your voice and your accent and your way of expressing yourself, and would not work well if somebody new, picked it up and started using it and hadn't trained it themselves. So this thing now cloud-based, and they're probably most likely being trained on a continuous basis with many different voices and many different accents and many different background noise situations and things like that. I think has massively improved their capability. But in terms of giving you like an exact number, I can't do that off the top of my head. It depends too much on the application and your your implementation and your own particular process to be able to tell you if it'll work or not. I have definitely, I guess what I can say is I've seen examples of chatbots that I know were implemented on the Watson conversation service that did not work very well. I've also seen ones that work pretty well. And so, if you're diligent in what you do, you can certainly create a chatbot that works very well and has a high degree of success in having a good conversation with a customer. But that just depends on how much work you're willing to put into setting it up and configuring it and testing it.
All right, so guys, we are running out of time already, so I think I am going to conclude the session here. Paul, thank you very much for your great time. So, all right, so I'm going to conclude the session now. All right. Bye, Paul.
All right, thanks. Thank you, everybody.
Yeah, so hope you are hearing the applause here. So, okay, Paul, bye.
Thanks, Sajid. Bye.